What's going on, everybody? My name is Alex Freeberg, and today we're going to be starting our intermediate SQL series. If you joined us for our last series, we walked through the basics of SQL, which is everything you needed just to get started. And in this series, we're going to be walking through some intermediate concepts to really take your skills up to the next level. Now, today we're going to be walking through joins, but let me show you what you can expect from the entire series for this intermediate course. So we're going to be walking through joins today, and then in future videos, we're going to be walking through unions, case statements, updating and deleting data, partition by, data types, aliasing, creating views, having versus the group by statement, the getDate function, primary key versus foreign key, and then we're going to have an advanced course, and this is not set in stone yet, but these are some of the things that I think I will be going through or walking through. We're going through CTEs, sys tables or system tables, subqueries, temp tables, string functions, regular expression, stored procedures, and then importing and exporting data. So with all that being said, let's get into it. All right, now let's get rid of me because we do not need to be seeing me for the rest of the series. At the very top, here are some of the things that we're going to be going through today, which are inner joins and then outer joins. And in the outer joins, we have a few different styles or a few different types of outer joins. Now, a join is a way to combine multiple tables into a single output. For now, we're going to be using the employee demographics and the employee salary table. So let's get a look at both of these tables and see what's in them. In our employee demographics table, we have employee ID, first name, last name, age, and gender. And then down here in our employee salary table, we have employee ID, job title, and salary. If you notice, they have a similar column, and that's going to be the employee ID. Now, when you're doing a join, you have to do this based off a similar column, and typically you want it to be a unique field. So we're going to be using the employee ID from both tables to join these tables together to create one output. So let's get rid of this real quick, and let's start building our query to join these two tables together. So the first thing we're going to do is an inner join. So let's do select everything. And let's do it from SQL tutorial.dbo.employee demographics. And let's do join. We can also say inner join, but join by default is going to say inner. And we're going to do SQL tutorial.dbo.employee salary. Now we have to join them together, which is what we talked about earlier, and we're going to be doing that based off the employee ID. So for that, we have to say on, and then we're going to say employee demographics dot employee ID is equal to employee salary dot employee ID. So let's run this real quick and take a look at the output. And let me pull this up real quick. So what we are looking at is actually both tables combined. We have the employee ID, first name, last name, age, gender, and then here's the salary, employee ID, job title, salary. Now an inner join is really only going to show everything that is the same. So in both tables, there are employee IDs of 1001 all the way down to 1009. But if you notice, there is data that is missing. Real quick, let's go down to this graphic and let's look at this inner join. An inner join is going to show everything that is common or overlapping between table A and table B. So what we are looking at here is exactly that. We're only looking at the things that are similar based off this employee ID in both tables. Now let's change this join to a full outer join. And let's run this and see what we get. Now, if you notice, the output is very different. So let's take a look at it and see why it's so different. If you notice, everything down till here is the exact same. So employees 1001 down to 1009 are exactly the same. But once we get down to row 10, it starts to get very different. Now we are joining these tables based off the employee ID. So for example, right here, Ryan Howard has an employee ID of 1011. But as you can see in this table for salaries, there is no 1011 employee ID. So it has nothing to link it to. So because of that, it fills in everything as null because it has nothing to match on this table. And vice versa, in the employee salary table, there's a person in here that's a salesman and there's no employee ID at all, which means all this information is going to be null. And we can see that in this diagram right here. So this is the full outer join right here. And what it is saying is we are going to show everything from table A and table B, regardless of if it has a match based on what we were joining them on. So even if table A has an employee ID, but there's no employee ID in table B, we're still going to show it, and vice versa. So now let's look at a left outer join. A left outer join is going to take the left table and say we want everything from the left table and everything that's overlapping, but if it's only in the right table, we do not want it. Now, what is the left and the right table? The left table is going to be our first table that we use. Our right table is going to be the second table that we use. So we're going to look at everything in the employee demographics table, regardless of whether or not it has a match on the employee ID in the employee salary table. So this is what that looks like. So as you can see, this is our entire table for employee demographics. And down here, we have 3 that have information in the employee demographics table, but have absolutely no information in any of the employee salary table because there's nothing to match it on. So this 1011 is not in this table. This 1013 is not in this table. And this one does not even have an employee ID. So we're not going to have a match at all. And if we change that to the right, you'll see the exact opposite. It's going to show us everything in the employee salary table. So now we have all of our information right here from the employee salary table. And if it doesn't match in this table, it's just going to have nulls. So down here we have 1010, and obviously there's not going to be anything associated with that because there's no 1010 in the employee demographics table. And for this one, we have a salesman with no employee ID. And since there's no employee ID to tie it to this demographics table, we're going to have nothing. And we can see that in the diagram right here. So for the left outer join, we're looking at everything in table A, which is our demographics table. And in our right outer join, we're looking at everything at table B, which is our salary table. Now let's pull this down a little bit. So far we've only been using the select star. So we've been selecting everything, and I only did that just for demonstration purposes, but you most likely would not be doing this when you actually use these joins. What you're probably going to want to do is select exactly what columns you want in your output. So for example, let's do employee ID. Let's do first name, last name, and let's do job title, and let's do salary. And let's try to run that really quick. And as you can see, it is not going to work. Now, why is that not working? It's not working because we have 2 fields, one in each of these tables, and we have to specify what employee ID we want, because that is going to drastically change what our output is. So we have an employee ID in this table and in this table. Which one do we want to use? So for this demonstration, let's use employee demographics.employee ID. And let's actually just do an inner join because it's easier for the output. Now let's run this and see what we get. So as you can see, we now have the employee ID, first name, last name, job title, and salary. Now we're doing this with an inner join based off the employee ID from the employee demographics table. But if we use the employee salary table, it should give us the exact same output. And that's because we're using an inner join. And an inner join is only going to show us everything that overlaps between both tables. But now let's try a right outer join. And let's run this. Now we're using this employee ID from our employee salary table. And since we're doing a right outer join, we're going to get all the information from our employee salary table, and it does not have to be in our left table, which is our employee demographics table. So if you look at the information down here, this 110 is in the employee salary table, but it's in this position because that's what we're looking at in our select statement. And then over here, we have our salary. And since we have information right here which is in our employee salary table, but there is no employee ID, our employee ID is null. Now let's change this to look at the employee demographics employee ID and execute it. As you can see, that 110 is gone. Now we just have this information right down here, and we didn't have the employee ID for either of these, so it's going to show it regardless, and that's again because we have a right outer join, and that's why we have no employee ID down here. Now let's do a left outer join. And it's basically going to do the opposite of what we just looked at. Now we're looking at everything from our left table, regardless of if it's in our right table. And so our left table is our employee demographics table, and we are looking at our employee demographics ID. So with the employee demographics ID, it's going to show us the first name and the last name, which is everything in our left table, our employee demographics table. And since for these IDs, or lack of IDs, it's just going to give us nulls in all of these places. If I change it right up here to the employee salary employee ID, and I execute it, because we're showing everything from our left table, which is our employee demographics table, we are still going to see our names. But since we're using the employee ID from our right table, now we're just going to have blanks in this information and this information. Now let's look at a use case for these joins. Let's say Robert California is pressuring Michael Scott to meet his quarterly quota, and Michael Scott is almost there. He needs like $1,000 more, and he comes up with the genius idea to deduct pay from the highest paid employee at his branch besides himself. So how does he go about doing this and identifying the person that makes the most money? Well, of course, he's going to come to SQL first. So we actually want to look at a full outer join real quick, and let's just look at everything. So here's what we have. We have the employee ID, first name, last name, age, gender, employee ID, job, title, and salary. Now, what information do we need to know to get the information that Michael Scott needs? Well, we need the employee ID. We want the first name and last name. So let's write all that real quick. So employee ID, we need first name, we need last name, and then we're also going to need the salary because we need to know who is the highest paid employee. So now let's do an inner join because we really only want to look at the employee IDs where we know what their name is and their salary is. And let's do this based off the employee demographics table. Really doesn't matter for an inner join, but let's do that real quick. So let's look at this. So we have our employee ID, we have our first name, our last name, and our salary. And we want to do it where it's not Michael Scott. And that's because Michael doesn't want to take away his own money, he wants to take away his employees' money. So let's do where first name does not equal Michael. And he knows that he's the only one that is not named Michael. So now we have our list, and let's do order by, and let's do salary. And let's execute this. And let's do descending so that we can get at the very top. And this is tough news for Dwight Schrute because it looks like he is the highest paid employee besides Michael. And so it looks like he is going to get a cut in his pay this quarter so that Michael can meet his quota. So that's just one use case. Let's look at one more use case. Let's start out by getting rid of this and looking at everything again. So for our next use case, Kevin Malone, who is an accountant, thinks that he may have made a mistake when looking at the average salary for our salesman. Now, Angela Martin is very good at SQL, and so what she is going to do is she wants to go in and calculate the average salary for our salesman. So let's try to get that information. So all we're going to need is the job title and the salary. So let's come up here and let's get job title and let's get salary and let's look at this. And now we only want to look at where the job title is equal to salesman. Now the very last thing we want to do is we want to say we want the average of salary. Now, since we're going to need to do a group by, we're going to have to get rid of this salary and just take job title right down here and do group by job title. So we're going to have job title and then the average salary. And there you go. We have the salesman and the average salary is $52,000. So Angela now knows to go back and fix what Kevin made a mistake on. So that's how you use joins. I will include this image in the description so you can go and look that up yourself if you are curious and want to look at that. That really helped me out when I was first getting started to kind of conceptualize and understand what kind of data I was pulling based on what join I was using. So I hope that was useful to you as well. In the very next video, we're going to be looking at the union. So if that is posted, be sure to check that out next. Thank you guys so much for joining me. I really appreciate it. If you like this type of content or got anything out of it today, be sure to smash the like button, smash the subscribe button, and I'll see you in the next video. What's going on, everybody? My name is Alex Freeberg, and in today's video, we're going to be looking at unions. Now, in the very last video, we walked through joins, and I thought it was appropriate to look at unions next because unions and joins are somewhat similar or closely related. And that's because in both instances, they're combining two tables to create one output. Now, what's the difference? The difference is that a join combines both tables based off a common column. And in the last video, that was the employee ID. So in both tables, we had an employee ID. And when you're selecting your data, you have to choose either to only select one employee ID, or you can choose both employee IDs, but they're in separate columns. And with a union, you're actually able to select all the data from both tables and put it into one output where all the data is in each column and not separated out, and you don't have to choose which table you're choosing it from. Now, that may not have made 100% sense, but let's look at it real quick in stages. So let's go down here and let's actually join this table together and see what we get. Now, the two tables that we're looking at is employee demographics and warehouse employee demographics. So over here, we have our employee demographics information. And then over here, or actually down here, we have our warehouse employee demographics. Now, right now I'm doing a full outer join. So we're looking at all the data. And if we were to pull this in to an Excel spreadsheet, we could just copy this and paste it over here and we would be good to go. And that's because we have all the same columns: first name, last name, age, gender, first name, last name, age, gender. But if we tried to combine this in a query where we had this information right here, it wouldn't work. We cannot get it in the same column, and that's where a union comes into play. So let's go back up here and let's actually run both of these. Now, as you can see, they have the exact same columns, and that makes it super easy for what we're about to do. All we're going to do is between these two queries, which are completely separate right now, all we're going to do is write union. So let's run just this. Now, because of the union, you can look down here and the information that used to be in the other table, which were in separate columns, are now added down below in the exact same order. Now, Daryl Philbin was actually in both tables. And the reason he isn't showing up multiple times is because this union is actually taking out and removing the duplicates, kind of like a distinct statement. Now, there's actually another thing called union all, and if we do union all, it is going to show us all of the information regardless if it is a duplicate or not. So let's run that real quick, and they are both there, but let's order by, and let's do employee ID. So now let's run it. And as you can see right here, these are exact duplicates. And so the union got rid of it because they were the exact same, but the union all kept it in because it is showing just the data as is. Now let's get rid of this union all, because the only reason why it works so well is because those two tables were the exact same. They were employee ID, first name, last name, age, gender. So they're basically the same tables, just with different information. So it made it really easy. But we have another table, employee salary. And let's look at these two tables. So these two tables are obviously very different. They hold different information. Now we would still be able to combine them. So let's do employee ID, first name, and let's do age. Now down here on the employee salary table, we will do employee ID, job title, and salary. Now let's use a union really quick and run this one. And it is still going to work. Now, why does this work? Well, first off, the reason it's working is because these data types are the exact same, or at least similar. So text and text, age, which is an integer, salary, which is an integer. It has the same amount of columns. So 3 and 3. So we have employee ID, first name, and age, and it's taking that from the first select statement. And it's still using a union to take the data from the second select statement. So it's still inserting this information. Now this is not what you want to do, because right here we have first name and it's salesman, salesman, and then our age we have 30, 45,000, and 45,000 is obviously not an age. So you want to be careful when you're using a union to combine two separate tables and make sure that the data you're selecting is the same. In the very next video, we're going to be walking through case statements. Thank you guys so much for joining me. I really appreciate it. If you like this type of content, be sure to subscribe below, and I'll see you in the next video. What is going on, everybody? My name is Alex Freeberg, and today we're going to be walking through case statements in SQL. A case statement allows you to specify a condition, and then it also allows you to specify what you want returned when that condition is met. So we're going to be using this employee demographics table that we're looking at right here. We're going to walk through the syntax of how to create a case statement, and then we're going to actually go into some use cases at the end. So let's start off by specifying what columns we want. Let's say we want the first name, we want the last name, and we want the age. Now let's just get that information. Now for our case statement, we're going to be using this age column. So we actually want the age to be in there. So let's specify where age is not null and run that. So now we have a pretty good look at it. And let's just order by age, just to clean it up a little bit. So now let's start building our case statement. So we're going to say case, and then we want to say when. Now we need to specify what condition we want to look for. So let's do when age is greater than 30. Then what do we want to be returned? So we want to return that they are old. Else, so that means anything that is not over the age of 30, we want to return young. And then you need to specify that you are done with the case statement, and so you'll write end at the very bottom. So this is our first case statement. Let's run it and see what we get. So as you can see, a new column was created, and if the person is over the age of 30, so 31 and up, they're given old, and if they're not over the age of 30, they are given young. Now we can do as many when and then statements as we want. So if we want to, we can also do when the age is between 27 and 30, then we want to return young, and anyone else we're going to call a baby. So now we have Ryan Howard as the baby. Anyone between 27 and 30, they're considered young, and anyone over the age of 30 is old. Now something to note is that the very first condition that is met is going to be returned. So if there are multiple conditions that meet the criteria, only the very first one is going to be returned. And let's demonstrate that real quick. So if the age equals 38, then return Stanley, because that is Stanley. And let's execute this real quick. So right here, I'm specifying that if it's 38, it should return Stanley, but he is right here, and it still says old. And that's because this condition was already met. Now, if we were to put this right here, it should work correctly. And let's try it out. So now because this condition is met first, it is going to return Stanley down here. So now let's get into our first use case. Let's start off by copying this and then commenting it out. I only did that because I don't want to rewrite it because I'm lazy. Let's get rid of that. And let's look at this real quick. We are going to join on another table that we have really fast. And that's going to be SQL tutorial. If you've watched my other videos, then you know this table. And we're going to do that on employee demographics dot employee ID is equal to employee salary dot employee ID. Okay, so let's just look at everything in these tables really quick. Now we are going to be focusing on the job title and the salary column, but we want their first name and last name as well. So let's start building that out. Let's do first name, last name, job title, and salary. And let's look at this really quick. So now we have our employees, and here is the situation. We had a fantastic year this year selling paper, and corporate has allowed Michael Scott to give out a yearly raise to every single employee. But not every employee is going to get the same raise, because our salesmen are genuinely the people who made us our money, and they're going to get the biggest raises, while other people really aren't going to get that big of a raise. So now let's go through and create a case statement to calculate what their salary will be after they get their raise. So let's start off by saying case and when, and we want it to say when job title is equal to salesman. So when they are a salesman, what do we want to happen? So this is where the calculation occurs. So we're going to take their salary, and then we're going to add their salary times how much their raise is going to be. So the salesman did really, really well, and we want to give them a 10% raise this year. Now, when their job title is equal to accountant, then, and we'll take their salary, we will give them, let's give them a 5% raise. Still very generous. There we go. And when the job title is equal to HR, then it's going to be the salary plus the salary times, and then we're going to do 0.0001. All right, and else we are just going to do salary plus salary, let's do parenthesis, times, and let's just give everyone else a 3% raise, and then we'll write end. Now let's take a look at our results. So here's what we have so far. We have our first name, our last name, our job title, and our salary. That is our current salary. And then we're going to have our salary after we get our raise. So I'm going to actually write that up here. So let's do as salary after raise. And let's execute that. So let's look at these raises really quick. So we have $45,000, and since he is a salesman, he gets a 10% raise, which is a raise of $4,500. So $45,000 plus $4,500 is $49,500. And as you can see down here, we have HR, who is making $50,000, as now he is making $50,000.05. So everybody got a raise. So that is our case statement. I hope that was helpful. I find myself using the case statement a lot when I'm wanting to categorize things or label things. And that's kind of what we did in the first example. And you can even do calculations like we did in this use case. So I hope that was helpful. Thank you guys so much for watching. I really appreciate it. If you learned anything from this video, be sure to like and subscribe below, and I'll see you in the next video. What is going on, everybody? My name is Alex Freeberg, and today we're going to be looking at the having clause. Now, the having clause I feel is a little bit unappreciated in the SQL community. I feel like it doesn't get a lot of love. And so today I want to describe how to use it and what it's used for. So before we use the having clause, I want to set up our query here. We want to use an aggregate function in the group by statement, and then I will show you how to use this having clause. So let's look at the job title, and let's look at the count of job titles. And then down here, we need to do group by job title. And let's execute this. And here is our job titles, and here's the count of how many people have those job titles. So now let's say we want to look at all the jobs that have more than one person in that specific job. So let's do where the count of job title is greater than 1. And let's run that. And as you can see, we're going to get this message right here. Now let's read it. An aggregate may not appear in the where clause unless it is in a subquery contained in a having clause or a select list, and the column being aggregated is an outer reference. What that is basically saying is we cannot use this aggregate function in the where statement. We need to use a having clause. So let's get rid of this, and let's say having the count of job title greater than 1. I did the same thing again. And we're still going to get an error. Now, why are we getting that error? The reason is because this having statement is completely dependent on the group by statement, because we are performing this after it has been aggregated. So this having statement actually needs to go after the group by statement, because we can't look at the aggregated information before it's actually aggregated in that group by statement. So now let's run this, and it worked perfectly. So now we only have the jobs that have more than one employee for that job title. So now let's look at one more example. Let's do the average, let's say salary, and let's get rid of this having clause real quick, and just to look at this information, and let's do order by, and we'll do average salary. So let's look at this, and we have 36,000 to 65,000. So in the middle we got 44,500. So let's use this having statement, and let's say the average of salary where it is greater than 45,000. And we actually need to put this right here, right after the group by and before the order by. So let's run this and see what we get. And it works perfectly. So now we're looking at the job titles that have an average salary of over $45,000. What is going on, everybody? My name is Alex Freeberg, and today we're going to be looking at updating and deleting data in a table. Now, what's the difference between inserting data into a table and updating data? Insert into is going to create a new row in your table, while updating is going to alter a pre-existing row, while deleting is going to specify what rows you want to remove from your table. So let's get going with the updating. So down here, Holly Flax does not have an employee ID, age, or gender. Now we want to update this table to give her that information. So let's do update. Now we need to specify what table we are going to be hitting off of. So let's do SQL tutorial.tbo.employee demographics. So now we're going to use something called set. And set is going to specify what column and what value you actually want to insert into that cell. So let's set her employee ID equal to, and it's going to be 1012. And we have to specify which one to do this to, because if we ran just this, is going to set every single employee ID to 1012, because we haven't specified that we only want Holly Flax's row to be updated. So now we have to specify where first name is equal to Holly and last name is equal to Flax. So now let's run this and see what we get. So one row has been affected. Let's see what we got. And there we go. As you can see, the employee ID was updated exactly how we specified it right here. So we also want to update age and gender, and let's do that in the same query. So let's set the age equal to 31. And instead of using and, we actually need to use a comma. So let's say age equal to 31, comma, gender is going to be equal to female. And let's run this and see what we get. There you go. Now let's look at our table. And as you can see, it was updated to 31 and female. So very easy to specify what you want. Oftentimes, tables like this will have a unique key, like employee ID is our unique key in this table. So I could easily just say where the employee ID is equal to, and then 1012. So it's an easy way to specify what employee you're trying to update. So now let's look at the delete statement. The delete statement is going to remove an entire row from our table. So let's do delete, and we actually need to say from, and we have to specify what table we want to be removing this information from. So let's do SQL tutorial.dbo.employee demographics. And now we need to specify what row we want to remove. So let's do where employee ID is equal to, and let's choose a completely random employee ID 1005. So let's run this and see what happens. So one row is affected. Let's look at our table. So there you go. That is the having clause. Definitely one that is good to know and is very useful in specific situations. Thank you guys so much for watching. I really appreciate it. If you liked this video or learned anything today, be sure to subscribe below, and I'll see you in the next video.